Right, in our third tutorial, guys, we have the following. They say determine the equation of a straight line through the points -2, 0, 1, and 2. And I think we have already dealt with this. Dealt already with this, but let's just look at it for the second time. So if I am to find the equation through the points this and this, the first thing that I need to do is to find the gradient. And I know that in order to find the gradient, I must just say this is my x1, my y1, x2, y2, and then proceed to say gradient equals y2 minus y1, x2 minus x1, and we can proceed to say 2 minus 0 all over 1 minus into minus 2. I want you to check this. Y2 it's 2 minus y1 it's 0. My x2 it's 1 minus from the formula, but my x1 it's -2. So I am introducing the brackets because to show that you have to multiply there. 2 into 1 plus 2, 2 over 3. That is the gradient. Okay, and then I choose any point from those two in order to find the equation. So I'm going to choose 1 and 2. Y equals mx plus c. My y is 2. My gradient is 2/3 and my x is 1. And I want to find c. 2 equals 2/3 because 2/3 times 1 is 2/3 plus c. And this would be 2 minus 2/3 over 1. I can simplify this. Lowest common denominator, it's 3. 1 into 3 goes 3 times. 3 times 2, it's 6. 3 into 3 goes once. 1 times 2, it's 2. So this is the same as 4/3 equals c. So y equals mx plus c. So write down the value of the gradient, 2/3, leave x, and write down the value of c, positive 4/3. And that's exactly what you have. Y equals this. This is very, very important. Or somebody might want to write this in a different way by getting rid of the denominator. How? If you have y equals 2/3 x plus 4/3, you want to get rid of the denominator, so you will multiply everything by 3. You would say 3 times y, 2/3 x times 3, 4/3 times 3. This into this goes once. You will have your 3y equals 2x. Remember, you'll have your 2x plus 4, because this into this goes once. So it's truly up to you how you want to write this. So this is also highly and highly acceptable. If they say write your answer in the form ax plus by plus c, you will write it in this form. Okay, secondly, they say to us, determine the equation of the following lines parallel to g at x equals 3x plus 1 passing through 1 and 2. So I want to find the equation of a straight line that is parallel to this line passing through that line. And what do I know about parallel lines? The gradient of this line, which we can say it's m1, it's equals to the gradient of that other line that passes through this point. This is something that we need to understand. So I already know the gradient of this line, which is 3. So if the gradient of this line is 3, the gradient of the other line is also 3, because they are parallel. But this other line passes through that line, that point. So y equals mx plus c. So I will take that point, y it's 2. The gradient is the same as the gradient of m1, which is 3. The x value is 1 plus c. So 2 equals 3 plus c. 2 minus 3 equals c, and minus 1 equals c. And I can now say y equals mx plus c. I can have the value of the gradient, which is 3. Leave your x and put the value of c. And this becomes the equation. If two lines are parallel and the second line passes through that point. And then where do we go? The third one. Determine the equation of a straight line that is perpendicular to p at x equals minus 2x minus 1 through 2 and 3. So if two lines are perpendicular, they make up an angle of 90 degrees. So if m1 is perpendicular to m2, the gradient of m1, when you multiply with the gradient of m2, you must get negative 1. Okay. So if m1 multiplied by m2 must give me negative 1, I know the gradient of m1, it's negative 2. I don't know the gradient of m2. But when I multiply the 2, I must get a negative 1. I want to make m2 the subject. I would divide by negative 2, because you can't translate this multiplication in between. We only translate if there's a positive and a negative. But what I do on the left, I must also do on the right. This into this goes once, and my m2, it's 1/2. And this gradient passes through that point. So y equals mx plus c. And my y is 3. My gradient is 1/2. My x is 2. You are numerator, denominator, and you are the same. You will go once into each other, leaving me with a 1. Okay, take to the other side, because you will have 3 minus 1, which is 2. Y equals mx plus c. Therefore, you will have the gradient, it's 1/2. Leave x, substitute the value of c. So this is your y. And if you want to get rid of the denominator by multiplying everything by 2, you'll have 2y equals x plus 1. I hope that we see that. Sorry, plus 4. Because y times 2 is 2y, 1/2 times 2, it's x, and then 2 times 2, it's 4. So you can also have it in this way. And then let's look at the last part. I'm just going to do it right here. They say determine the equation of a straight line with an inclination. So we are given theta as 135 degrees. That passes through the point -2 and 2. And in the previous tutorial, we introduced the formula. The gradient equals the tangent of theta. The tan, what is your angle? 135 degrees. What is tan of 135 degrees? That is the question. I think the answer will be -1 there. And if that is true, y equals mx plus c. My y, it's 2. My gradient, it's -1. My x, it's -2 plus c. Negative times negative is a positive. Take to the other side, c is equals to 0. Y equals mx plus c. Write down the value of the gradient, -1, leave x. Write down the value of c, which is 0. And this is the same as minus x. And you are done. So this is all what I wanted to share with you when it comes to the straight lines. I will see you in the next tutorial where we will be looking at the hyperbolic functions.